can hear me, right? Thank you. As Tim said, I have to keep you awake for the next half an hour, correct? Yes. And as a result, I'll show you a lot of math, I promise. All right. But anyways, let's get started. So as Tim said, this is my third year at this conference. And I love this conference because among the few places, as Christopher says, in Silicon Valley, where you can talk industrial and have an audience that will pay attention. So I hope you do pay attention. And I'll try to give a brief overview of where we are in our journey of industrial AI and what is next. So very few math equations, I promise. So this is the slide that I first showed in 2022. Then I used the slide in 2023, and I'm using the slide again this year. And the reason I use this slide is because it turns out that I was right about this 3 years ago. But I think some of these things we all agree with now, that AI is a fundamental enabling technology. It should be viewed as a technology that does transform a bunch of other technologies. Okay, so I will continue my discussion as the slides come back on so you guys don't go to sleep. So you should, and we started thinking of AI fundamentally as a fundamental technology that will change everything, that will impact every horizontal. And that's the perspective I bring today. That's not me. I do not know about semiconductor growth market. Okay, all right. So this is a semiconductor growth market. It's gone away. But let me continue with my talk. So I'll go to the next slide, which you can't see. But the point being, the first slide was just a generic overview of what we think of AI's trajectory. And I think we can skip that part. And the next slide is actually more visual. But anyway, so the way I think about any organization, so since I am the general manager for AI research at Hitachi, and Hitachi is a very diverse company. So it has energy sector, a lot of the transmission distribution network that is powering this building, for example, would come from Hitachi. Hitachi makes rails, semiconductor etching devices, as well as a digital footprint. So it's a very diverse company. And as a leader there in AI, I have to think about how AI impacts all of Hitachi. And given that view, what are the research investments that we should make? Which area of AI should we invest in? And this is sort of a global investment, not just in Japan, but we have a team in North America, in Singapore, in India, and China as well. So how do we allocate our sort of AI resources globally? So this is one way I think about how AI impacts any organization. And there are 4 boxes, I think 2 or 3 apply to any organization. So one way to think about AI is how does it impact your support functions, right? So suppose you're a manufacturer, manufacturing is your core component, right? So that is where your IP is, but you still need legal, you need HR, you need finance. And AI process transformation will impact all of that. So that is box number 1. Box number 2 is improving efficiency of internal Hitachi core processes. And this can be your core processes, and you can replace Hitachi with your organization. But the point is, if you're doing design, then that's your core IP. And that is a sort of the AI IP that you want to build. Then Hitachi does offer a lot of products. It's a product-based company. So can we introduce AI to the products? And finally, we have digital offerings as well. So what kind of AI solutions do we build for our customers? And I promise this is the only time we'll mention Hitachi. And it'll be, rest of the talk will be much more general. All right? So the title of the talk is Notes on Industrial AI. So, and this is Industrial AI Conference. Unfortunately, I'm the first one to define industrial AI in 2 days, but I'll make up for that, right? So what is industrial AI? So industrial AI is the application of AI, machine learning, related technologies towards addressing real-world problems in the industrial societal domains. And this is a broad definition that I use as my guiding principle as to what area we are working on. And since there is so much hype around generative AI, I have to state point number 2. In our world, generative AI is important, but traditional AI, optimization, simulation are also extremely important. And industrial AI has a unique set of challenges that very often people miss in Silicon Valley. I think Christopher said earlier, if Panasonic makes a mistake, someone dies. Hitachi makes a mistake, someone dies, right? So we are in that world, of physical world. So reliability is very important. So for example, all of you drive a car, you sit in the car, you push a button, and your seat moves forward. So can you tell me how many motors are there in a typical car? Guess. In luxury car, how many motors would be there? Around 40 to 50 motors. But you don't ever notice them, right? You don't even think about them because they're extremely reliable. They always work the way you intend them to work. And this is the level of AI that you would need if you really think that AI would transform the industrial world. So reliability is a key word. Small data, right? So we don't have trillions of data points to train a model on. So we have small data, we need reliability over this small data, and we have to incorporate deep domain knowledge. I think that was mentioned by Christopher earlier as well. This is a key to using AI. Explainability is very important, and then you have to be able to model a system of systems. Again, back to the example of a car essentially is a system of systems. So there's a tier one, so there's a car maker, say Toyota, and then there are tier one suppliers, tier two suppliers, tier three suppliers, tier four suppliers, right? And your components will range all the way from the tier four till you assemble the car, right? That's why it's called car assembly. You're not manufacturing a car, you're assembling a car, right? So there is a difference. And so you are essentially have to be able to model this very complex system of systems. My final, and the data type is very heterogeneous, right? So large language models came out because Silicon Valley dealt primarily with text data, right? And now you are incorporating vision data. But in our world, you have sensor data, event data, maintenance records, operational data, acoustic data, vision data, multimodal documents. Let's just sort of name a few. So these are some of the challenges and characteristics of what industrial AI is. And the top quote, this is not from me, this was a discussion between Jensen from NVIDIA and the Microsoft CEO. So last year at NVIDIA's GTC, they said third wave of AI, which impacts the industrial world, will be the most significant impact of AI in the world. And so give credit to that. Right? So now let's take a deeper, slightly technical look. So it helps for me to think in value chain. So this is sort of a typical value chain in manufacturing, but so many industrial processes. So you start from tendering, design, you get procurement, you produce, you install, you maintain, and you do customer experience. And typical industrial AI was the one, say, circa 2020, was focused on production, installation, and maintenance. And he was using traditional machine learning techniques to make these processes much more efficient with much fewer errors. And the thing that we learned as we built very many solutions in this space was the benefits of AI work through process transformation. I think this is a fundamental fact people forget when they think that AI suddenly will transform everything, right? So if you think of any industry, it runs on processes. Suppose I'm maintaining a truck. I'll give you that example, right? So a truck comes in, driver brings in the truck, he says something is wrong with my truck. The technician talks to the driver, says, oh, this is what is wrong with the truck. Then he goes, plugs in a dongle, downloads the fault code, then goes to some sort of a diagnostic tree provided by the OEM, will try to fix the truck. Now, AI cannot transform the whole process. AI will transform one step in the process at the time. So the step that we transformed very many years ago for one of the largest fleet companies in the world was the step of replacing the diagnostic tree with the machine learning model. So when the technician inserts a dongle into the truck, downloads the fault code, we will say, okay, this is the repair to be done based on the fault code. But AI works through step-by-step process transformation. So when Bill Gates says that the effect of generative AI is overestimated in the short term and underestimated in the long term, this is exactly what is meant. Because to gain the gains that we imagine from generative AI, they will be step by step, will be process transformation by process transformation by process transformation. And eventually they will accumulate to a large change. But the slope will be like this. And that's what you see when people talk about disillusionment or the trough of disillusionment, Gartner hype cycle. It's not that the technology is not working. It is working as intended, but people anticipated that it is like a switch. It's not like a switch that transforms everything. It's a process transformation. And you have to think about your processes. And in this sort of industrial AI, we looked at maintenance repair, operations optimization, quality, supply chain, end-to-end optimization were the key horizontal areas. And what it resulted in was these set of canonical problems that we solved. And this was again 2020, 2021. These problems are still all important. They are not going away because the value chain is still there. But this is the sort of problems we were solving in maintenance repair, in operations, in quality, in supply chain management. Right? And this set of problems essentially is discovered through interaction with hundreds of customers that I've spoken to, both internal to Hitachi and outside of Hitachi. And my belief is that this sort of covers 80% of the industrial problems that you can do or address with machine learning and AI, right? So what happens when generative AI comes in? So I'm going to sort of show this pictorially. And so generative AI is now enabling us to make much more richer industrial applications. So if you think of the three key building blocks of industrial operations, from a workforce to your processes to assets, and you look at the type of data that you're trying to get from them. So if you look at the workforce, there is a lot of natural language communication that's happening. It's through Teams, through email, through comments. And so a lot of the solutions that you will build will have a preponderance of generative AI-based techniques. If you look at processes, then you get to a point where you still have a lot of textual data, but now a lot of sensor data, event data comes to pull in, and you might need to sort of bridge both generative AI and industrial AI together, and I'll show you how we are doing that. And finally, from assets, it's primarily sensor data, event data, and a bit of manuals. And you see, so this is the interplay of industrial AI and generative AI that we are trying to achieve at Hitachi. And this is, I think, the future of industrial AI in some sense. I'll give you one very quick example. So this is repair recommendations, historical repairs. So this is the thing I talked about earlier, right? And this is deployed at Penske, which is, I think, it's this country's largest fleet company. The solution has been in operation for the last 5 years, maybe 6 years. It's been used at 700 shops. More than 500,000 trucks benefit from this. So the idea was very simple. Okay, so what happens is the truck comes in and you want to suggest a new repair. So what we did at that time was we built a model using historical repairs because Penske had collected a lot of historical data from their truck. So this was when the truck came in, what was the driver complaint, what was the fault codes that you could download from the truck, and what was the correct repair the driver did. And we modeled as a traditional classification problem, and it was at the end of the day, the model was fairly complex. It was an ensemble of multiple classification techniques, but we solved it sufficiently enough that it was a huge success for Penske. Now, when we have generative AI, we are augmenting this with service manuals as well. So sometimes the right answer is not in the historical repair data. If it's a new kind of truck, for example, if it's a new make model year, they're onboarding a different vendor. So then you might not have enough historical data. So at that time, you have to revert back to manuals. And this is where sort of generative AI's ability to understand text, to model figures in the text to some extent, turns out to be useful. So this is an example how generative AI augments a problem that already existed, that was being solved through some traditional AI, but now with generative AI, we can augment. The solution becomes much more powerful. I think this will happen with all the slides. So you'll have to look over there, I guess. So I think something died. So this is, and there's been a lot of talk of graphs, so I want to give you another example of how we are using generative AI for graphs. And I have a quick demo as well. But one of the things that you can do from when you get a manual is if you want to find the right repair, you can either read the whole manual, but what the savvy organizations do is they build something called a fault model, right? So if this is the fault, you can traverse in the graph, and from equipment ID, you can say this is the fault, this is the cause, and this is what you do. So generative AI allows us to extract such fault trees from a manual. And now you can query the fault tree directly. So this is a very long video, but this is one of the smaller problems that we did. The idea is you can build a fault tree on the fly from a manual, and that can be any manual. So we took some open source manual, and so you can open. Okay, I will let it play. And then once you have uploaded the manual, you are able to extract a fault tree. It's just a graph-like structure. And then once you have done that, you query it, and it gives you two things. It grounds the answer, meaning it says, look, the answer based on the fault tree is here. And it tells you where in the manual you can fetch, you can check as a human where the answer is. And as a result, so not only do you get the good answer, but from a domain expert, it also gives them enough confidence in machine learning to be able to operationalize the question. Right? So this will turn into a pretty complex fault tree. So these are all components and subcomponents. As I said, in industrial world, you have to think about systems of systems, right? So, and for every component, subcomponent, you're going to get a fault and an action. And then you can generate this, store it, and then you can some sort of a graph rag over this to given a new query and get the right answer. All right. So in the interest of time, I'm going to skip this and go to the next slide. You're missing all my witty statements on the top, but that's okay. Let me go to the next slide. Okay. So in some sense, I give you two examples of how generative AI is impacting industrial AI. So this is more of an abstraction. So these are as I've again in the last year and a half, I've spoken to a lot of customers, both internally, externally, in terms of how they plan to use generative AI. And so these are the three areas in which I think there is an expansion of what AI could do. So one is upstream processes. So now we heard a lot about material sciences, materials discovery, right? So in the design, very initial design process, whether it's the discovery of a material or you're trying to design something new, generative AI can play a role. RFP response becomes a very big use case. There's something I'm hearing again and again from multiple customers. They have to, if you've seen an RFP for an industrial product, it can have thousands of questions sometimes. And what you really want to, and the humans has to fill that out, the whole thing. And you can make that process much more efficient with generative AI. This is another example of a real-world use case, which is essentially about process transformation. So there is a process today, or RFP response, and then we are trying to change it with generative AI. On the downstream process, customer support, everyone has heard of. The most interesting to me is the OT software code completion. Right? So OT has operations, have a lot of software. The CNC machine, for example, has CNC software, right? And now we are beginning to use generative AI for generating OT software. It is not straightforward because there's not enough of OT-specific software in the open domain. So you cannot use an existing tool to simply, the way you would say want to create a website and you can simply ask ChatGPT, that would be fine. But say if you were to try to generate CNC code, it would not be of the same quality. So you might need to do your own fine-tuning or additional pre-training of your language model to be able to generate OT code. And especially if the OT code is being used in the physical world, then it needs to be fault-tolerant as well. So those are some of the guarantees you need to be able to push the OT code to production. Right? So there are some unique requirements of OT software, but we do believe that that is another interesting use case of generative AI that will evolve over time. And so, and this is how I define Industrial AI 2.0, which essentially means now initially we were focused on these three steps in the value chain, but now with generative AI, we can tackle the whole industrial value chain to some extent. But the other thing I forgot to mention was The other two places where we are seeing a lot of generative AI use cases is process knowledge extraction. So meaning, as I said earlier, industries run on processes, but these processes are not documented. People don't know what's happening, right? So you want to use generative AI to understand process. You can talk to individuals. So I talk to someone, says, how do you clear an invoice? So that person will tell me, how do I clear an invoice? So I take that verbal input and I convert it into a graph of steps. And then that I can verify with the human. And then that's how I can do process, understand the process. And once I understand the process, then I can say, okay, this part of the process can then be transformed with AI, right? So this is another area. And then intermediation through speech and metaverse. I think there was a talk yesterday on speech as well. I believe that speech will become a very important modality of interacting in the physical world. And that is another thing we are seeing right now. So back to this slide. So this is how I see industrial AI 2.0, right? This is where we are now, okay? And I'll give you some examples. So we are building a metaverse for X. I think you have heard something similar story from NVIDIA as well. But the idea is, can you help do real-world operations with the help of metaverse? So for example, the use case that we have is a worker is in the field and they need to fix something. Say, I need to fix this guy, right? This is not working, and I'm a new untrained worker. How do I do? So someone in the back office can tell me, maybe look at the operator, not look at the projector, something is wrong with the projector. So that kind of interaction, mediation can be done through metaverse. So this slide said Industrial AI 3.0. Okay, so you don't see that. But this is Industrial AI 3.0. And the world, I think, that we are approaching towards, maybe in the next few years, is this sort of agentic architectures where you will have not only virtual agents, which we think about when we think about ChatGPT, but also physical agents, right? So as a human, if I'm a worker in the field, and this is very true in Japan, for example, where the working age population is dramatically sort of going down, and you might not have as many field workers. So two things will need to happen. One is the field worker will need to be able to do multiple kinds of industries at the same time, right? So I can't have someone who only knows rail or who only knows energy, right? Maybe a worker will need to do multiple domains. And at the same time, on the work side, there might not be enough workers to do a job, right? So to augment the worker in the field, you need some virtual agent that can provide him or her the right information at the right time. And although maybe you will need a robot to help him or her do his job. A very simple example is, I am trying to fix this guy, so I'm climbing up. I don't know where the projector is, but maybe at the back. So I'm at the projector, and I need a spanner, right? So I can ask the robot, can you go fetch me a particular spanner, for example? Or can you switch that light on and off to see if this is working or not, right? So simple things like that is where a robot, some form of automation, physical automation will help. So for one of the key things that we're looking at in the future is this idea that the way generative AI is augmenting the white-collar worker today, can we use a generative AI to help the blue-collar worker, the frontline worker? And a lot of our research is sort of focused on this idea that there'll be agents, they will be interacting with each other and doing stuff, right? So we talked about industrial AI 1.0, 2.0, 3.0. And so what are some of the key challenges that we're working on right now? So this is not just true of generative AI, but for AI to be really valuable in the field, you need sort of few properties. The statement at the top says, we need AI to be reliable, cost-effective, and perform valuable tasks, right? So we all use ChatGPT, at least I use it a lot. It performs some valuable tasks for me, but the set of valuable tasks that it can do today is still limited, right? So in the industrial world, you really want AI to be able to do mission-critical tasks at a low cost, and the complexity of tasks should be high. That's what I want. So I want to move from somewhere here to somewhere here, right, in a three-dimensional space. I tried to take this picture using ChatGPT, and this is an open challenge. If you can get ChatGPT to draw this curve, not this figure, that'll be very impressive. I tried for quite some time. It cannot draw a very simple three orthogonal dimensions for some reason. I don't know why. Anyways, and these are some of the areas that we are focused on the right-hand side. I know I'm blocking your view, but it says domain, multi-domains, domain-specific small LLMs. So people talk about domain-specific LLMs. To me, that is slightly ambiguous. So for example, if you think about the power industry is generation, transmission, and distribution. Right? Do I make one model for the power industry, or one separate for power and generation, for transmission and distribution? And there are subfields within that as well. So when we say that you want to make domain-specific model, the definition of domain is still not clear to me. Right? So domain, multi-domain specific smaller language models. Industrial multimodal foundation models, another area of work that we're working on, especially on acoustic data and time series data, how to marry that with other modalities like text. Agent design infrastructure, I think everyone understands that. Agentic AI, method for reliability and fault tolerance is also very important for us. Physics and science-driven ML is also extremely interesting to me personally, because I think that is what adds to reliability. That's what makes AI much more useful in the physical world. So can I infuse physics into my machine learning models? And simulation and reinforcement learning for planning and optimization. There is a problem we are solving. For example, if there is a train disruption, how do you reschedule your trains? This is a classic RL problem, very hard, very interesting, but real-world applications and successful. Explainability and ethics, and energy-efficient machine learning. So these are some of the core sort of research areas that we are working on from a research standpoint for us to be able to get to Industrial 3.0, which is this vision. I want to sort of, on a slightly technical note, that these three papers that I would recommend everyone read to, at least to get to my thinking where I am. So the first two are from DeepMind. So one, this is learned global weather forecasting. So what they did was they built an extremely large model over weather data to be able to predict the trajectory of a hurricane. So this is another area which is not generative AI, but I think for us to be able to solve real-world physical problems, we need to be able to make models that can look at large amount of time series data and be able to make a prediction. So this is applicable to supply chains, it's applicable to any system that you want to do. The second means AI achieved silver medal standard solving international math Olympiad problem. This was a few weeks ago, months ago. The paper is not out. Alpha, this is just a blog post, but there is an earlier paper called Alpha Geometry. And so you should try to read that. So that talks about neuro-symbolic computation. So idea is you can combine machine LLMs with some form of symbolic computation. And that marriage of symbolic computation with LLM is where you can get a lot of results that are verifiable. And because you have to, this is a proof, right? So this is, you're trying to prove a theorem. And that is where, for AI to be really applicable, you will need that technique. And the third paper is not a paper. This is a blog post called Automated Programming, Symbolic Computation, Machine Learning, my personal view. This is not my personal view, but Bruno Buckelberger's personal view. And it will really help you understand and disambiguate the hype between, will this lead to AGI? And how symbolic computation and machine learning and general programming are applicable, how AI might impact the software industry. So this is just sort of, I wanted to put that out there. And what is in this, the title of this slide is Industrial AI N.O. And I was talking to Fung earlier. 5 years ago, we had this idea of AI of AIs. Right? This was 2017 or 2018, when Hitachi, we composed this idea that every system, every small system will have an AI. And eventually, you will need to have these AIs talk to each other. We didn't know how that would work, how that would happen, but that was the view that we had 5 years ago. And I still think that is going to be possible. So where we are today, maybe somewhere here, traditional generative AI, right? So now we are trying to get to agentics AI. And I think what you really need is multi-scale, multi-objective AI, right? So agents today are still simple, but for us, for an agent to be able to perform a complex task, they will need to be able to have, and especially if you're going to depend on things like reinforcement learning, you need to be able to do multi-objective optimization at multiple scales of decision making. And from a physical systems complexity, you need to be able to model very complex system of systems. And we are somewhere here today. And I don't know how we will get there yet. Those are research problems. But that's where you need to get. And that point, you will have AI of AIs. It is not the same as being conscious AI. I'm on the last slide. Despite all of this, like on my last note, I strongly believe humans will drive the change. It is the humans who know the processes, who know their industries. And if we can tap their knowledge with AI, that's where the future is. And with that, thank you very much.
Hi, Chetan.
Hi.
As we talk to each other and we say, you know, you and I have been doing industrial AI since before it was cool.
Yes.
Right? And so you've had to learn and unlearn a lot of things. Can you share with this audience what you've had to unlearn? Like the stuff that used to be important or accurate that you need to think about differently to succeed in this new wave of industrial AI?
I think one example, and I'll hew to what Christopher said, right? So last year, 2 years, year and a half or so ago, there was this huge generative AI thing, and everyone in my management was saying, oh, what is Hitachi doing generative AI? Let's build some very large language models. Right? And I said, let's take a step back. We don't know how to build very large language models in the first place, and we don't even know how useful they would be. And I think as an organization, we learned and unlearned that. Like, so maybe for industrial domain, for particular domains, the small language models are what is important. And I think to me, one thing has been constant in some sense is the value of, our team is very diverse. Not only machine learning people, but optimization people, simulation folks, and people who are hardcore mathematicians. And I think to me, AI has never been simply about, being able to recommend the next product or the next black dress or the next phone or whatever it is that people were recommending earlier. And once you take a step away from the social media world, you realize that to be able to solve real world problems, natural language processing is just one of the tools that you need. And you need to have access to much wider variety of tools to really have an impact. So that is the one thing that we're constantly learning again and again.
Thank you. I have a question. What do you think of the temporal information being part of the industrial AI 3.0? And because all the sensor data we talk about is really content, and contextual information very, very critical in industrial applications.
Yes.
So the temporal information, how do we capture that, and how we leverage that information to really reach the future goal?
That is a very good question. I think both the question of temporality and causality are not very well understood. Right? Humans have very well-driven heuristics because of evolution about causality and as well as temporal nature. And our abstractions work with that. So that's why we're able to move in this physical world, because we understand these things very well. Even when you try to use these large language models kind of structures for, say, time series data, they ignore the time. They look at them as sequence of readings. And the moment you ignore time, you're losing a lot of very valuable information. So one of the things that we have been working on is something called FNNs. So which are essentially, they're trying to do for time series what CNNs did for images. So meaning you're trying to represent time series in terms of basis functions. So these are called functional neural networks. And I believe these are much better constructs if you want to model time series compared to simply looking at them as sort of just sequence of readings. I think that, and as long as we adhere to that sort of a model, I don't think we'll have success with dealing with time series in a more general way. For specific use cases, yes. But if someone wants to make a foundational model for time series data, they'll have to incorporate the temporal nature of time series, not just the sequential nature of time series. And causality is a very open problem. I don't know how we get there, especially with the current generative AI paradigm.
Thank you, Dr. Chetan Gupta. Sure.